session of Zero Build Forum. We are trying to demonstrate that energy efficiency, renewable energy, and green hydrogen synergy is very important for the future of global Green Deal, which is presented by International Renewable Energy Agency, and also European Green Deal, and for the countries and for the cities, 100% renewable cities. So we need to do hard work, and we see in the horizon a solution which is renewable, but somehow we need to get all together ready and prepare the infrastructure so that this becomes possible. So resources available everywhere, the radiation and heat and illumination, the light of the sun is available everywhere, free of charge. Nobody can privatize and sell each other. And also the kinetic energy of the moving air is available. So the resource is free of charge. You don't need to go and look for petroleum, natural gas, and how big the resource are, discuss about it. This is funny, and renewable energy sources are infinite and available. So we know that we were missing in 1850s, 1970s. After 1970s, human beings developed with the initiative of European institutions and International Energy Agency, working groups, and implementing agreements. The technology was developed finally. And now we have the cheapest electricity for the moment in the electricity production from renewables. And we are looking forward to dissemination of renewable energy implementation in industry, transportation, and other human activities. So our panelists are really globally known institutional people, and individually. We know that Professor Oktik is a teacher in Turkey of renewable energy and basically photovoltaics, and we learned a lot from him, and now he is one of the leading scientists. And Professor Heperkan is already one of the unique peoples in energy efficiency in Turkey, and we know young friends Julien and Yong are very important institutions, International Renewable Energy Agency staff, and representing this good quality. And I'm a professor of renewable energy, and also we have supported establishment of International Renewable Energy Agency as EUROSOLAR Bonn, European Renewable Energy Association. Our president at that time, unfortunately he died, Hermann Scheer, was in the German parliament together with Hans-Josef Fell and other party members who believes in renewable energy. They initiated the establishment of suggestion of International Renewable Energy Agency, and now we have, and doing a very good work in the United Nations. Earlier we had only Atomic Energy Agency. Now we have in United States, in United Nations, and International Renewable Energy Agency, who is defending and trying to disseminate all countries in the solution direction. So in this content, I would like to give words to first Julien and Yong to tell us about what's happening, what International Renewable Energy Agency is doing, and what they are planning. We are aware this global renewable energy deal. We know that the studies are already made on socioeconomic effects of transformation of the energy systems, like the welfare and gayri safi milli hasıla. What is it in English, Professor? Gayri safi milli hasıla. Hocam söylesenize, Hasan Heperkan, aklıma gelmedi. Yaşlanıyorum galiba. Gayri safi.
GBT.
Global Domestic. Gross domestic product.
Income.
Okay, so we have in the socioeconomic study of the International Renewable Energy Agency, we know that in the different scenarios, like Paris Agreement scenario, or transformation scenario, or deep decarbonization scenario, we know that if we pay $1 today, we get back $3 to $8 back in the future. So whenever we stop doing mistakes, this is more profitable in the long term. So in that structure, I would like to give first the words to Julien and Yong. You have about 20-25 minutes. I made my presentation a little bit short together. Then Professor Oktik, and then Hasan Heperkan. Please take the floor and explain us how International Renewable Energy Agency is doing, and what's the expectation of International Renewable Energy Agency in the scientific committee and governments and other stakeholders.
Okay. Thank you. Thank you very much.
We cannot hear you. Please unmute. Okay, that's good.
Now you can hear me. Okay, sorry. Yeah. Thank you very much for the kind introduction, and as well as for the invitation and to the IRENA, International Renewable Energy, to participate in this very important actual forum, and the Zero Build in the 2020. And this presentation, we're going to have a joint presentation, and me and Yong Chen, and leading the sustainable energy, urban energy team, and also there's my colleague Julien is going to join later and to present, dive in one of the tools we developed called planning platform for urban renewable energy. And okay, please allow me just give a few words about the IRENA and International Renewable Energy Agency as an intergovernmental organization. We work with the basically government and provide technical assistance and also advisory services to the member states. And by now we have 161 countries and joined the IRENA. So it's over about 10 years. We started, founded. The IRENA founded in 2011 and headquartered in Abu Dhabi, and we have one center, Innovation Technology Center, and based in Bonn. And so that is the overall of IRENA. About 3 years ago, we get into the urban energy and the topic, and given the reason, as probably everybody already very familiar with, after the Paris Agreement, and cities given a more important role to contribute to mitigation and as well as adaptation, because they are actually more and more impacted by the climate change. So that's a little bit the political background. And technically, I think the cities and currently they are politically willing to engage and to get the trying to benefit from the surge of renewable energy and development globally, but also they are also aware that they need some capacities and also tools, knowledge, and this is they can feel comfortable use. And so this is one of the reasons why we develop a knowledge part, and as well as this tool that's for helping the cities to plan their own energy system powered by renewables. As the professor already pointed, and the global, the energy landscape has been dramatically changed over the past, years and even longer decades. And also looking forward, and the climate change is one of the biggest challenge we have to deal with, and the renewables be part of the solution. But we also realize, renewables alone cannot achieve the goal that we're trying to achieve. That's under the Paris Agreement, and there's an energy efficiency need, And also there's other energy carriers like in the green hydrogen has also a great role to play. And next slide, please. Yeah, according to our study, and we did a global study on what's the role renewable energy can play to deep cut. And according to our study, this is a renewable energy together with energy efficiency can achieve and 75% of the emission and the reduction that's needed in order for the world to keep the temperature rise below 2 Celsius by by the end of the century, and the cut need to be done by the middle of this century. And and for the rest of there's need also the electrification. There's other sectors need to be coupled and with the power sector in order for accommodate the greater share of renewables in the power system. So that's and there's also this including energy and carriers and from such as hydrogen. And recently, this has been quite interesting and hot topic to discuss as a promising energy carriers to decarbon our energy systems, and especially for those sectors that are difficult to decarbonize. And next slide, please. And okay, since today's topic is a building, so I think this is very important. As not only the current buildings, have a big contributor to the CO2 emissions and also the big energy consumers, but also if you're looking into 2050, there is still the 2.5 billion and people and to going to move and become city dwellers. So this is how actually we power the buildings in future is extremely important. And we gradually can see that the renewables are going to play more and more important roles and in future. And we done study, and those are the results that we can show on the slides. And we see this is for electricity and used in buildings can reach actually to 68% and in share by 2050. And but the non-power, especially directly use of renewable energy, is going to also play a very important roles, especially like geothermal and the biomass as well. For the as the professor already pointed out, the efficiency is very important. So that's energy building energy efficiency is a topic that's never been actually been aboard. There's a lot of progress and need to be made and on the energy efficiency and aspect. So and also there's another important point I want to make here is that without the efficiency and improvement and the just installing renewables, it's going to be a little bit pointless, because one way you lose waste a lot of energy, and one way you want to add more renewables. So first we have to actually cut energy demand from the buildings before we seriously considering how we add what would be needed actually to power the buildings. And all of this, you can see this is the cities is an extremely important role to play in this settings. Next, please. And so this is our city team. Actually, we develop 3 components currently to knowledge. One is the database, and we have the target renewable energy target database at the city level, and also the analyze the locally available renewable energy resources, and as well as the power plant actually nearby those cities, and then trying to identify where the options or opportunities could be, and how the cities can step up their efforts and in setting up a higher target, and also moving to the renewable pathway. And technologically, and we provide some knowledge and in terms of how the renewable energy technology and can be used in urban settings. So covering both the power and also this is thermal as well. And we also done the case studies and for China and also Costa Rica. Another thing, important element of our program is that we develop a planning platform for urban renewable energies. And as Ren mentioned earlier on, as this is basically addressed some challenge that the cities are right now facing, and also we, after thorough reviews of existing tools, we identify there is a lack of a tool that can have a stronger and greater focus and on the renewables that's being used, can be used at the city level. And I will hand it over to my colleague Julien, and to deep dive into actually the tool, how the tool can operate, and how that can be helpful and for planning urban energy with the greater share of renewables, and especially with special focus on building sectors. Julien, the floor is yours. Thank you. Thank you very much for your attention. Julien, you probably need to unmute.
Yes.
Yes.
Can you hear me now?
Yes, we can hear you.
Yes, okay. Thank you. Perfect. Thank you very much, Yong, for this introduction. And as you mentioned, the second part of our presentation will be dedicated to the introduction of IRENA'S planning platform for urban renewable energy. The platform is a comprehensive approach. It's built with the integration of different modules in order to tackle the challenges for the integration of renewable energy in cities, in order to address the complexity of different solutions which would facilitate the introduction of renewable energy in cities, in order to reach towards a net zero carbon cities. So as we mentioned already, it's important to understand the trade-off between efficiency measures, which, for example, can be applied at the building scale in order to reduce end-use consumption. For the building, we are focusing more on the building, but also for the different sectors. So the tool itself is built in a bottom-up approach in order to understand from a building to district to city scale at which level some energy system measures could be applied in order to better understand the trade-off between distributed energy system and more centralized approach, for example, considering heating and cooling network, and as well at the city scale, different strategy for the mobility, for example. So electrification of the vehicles, or for example, increase of the share of public transportation. The platform is built in a way to keep granularity, which is high enough for the level of the analysis, in order to help city, to assist city in better estimate of the potential of integration of local energy. So what we are looking at is making optimal use of the availability of local renewable energy resources. We are looking at the sector coupling opportunity, for example, using multi-energy carriers, looking at the security of supply, more from a technical point of view. But we are also integrating the possibility to provide a picture on investment and operating costs for the supply side measure, so integration of system at a distributed scale. So the goal is to be able to answer different questions, such as, for example, effectively leverage emerging technologies, but also looking at the trade-off between efficiency measures on the demand side or on the system side. Thus, in order to maximize the utilization of the local renewable energy resources available. So if we deep dive a bit in the methodologies, the tool is built in order to overlay geographical information system databases on the different perspectives that we need to take into account in order to understand how we could facilitate the integration of renewable energy. So we have, for example, the demand layer, which focus mainly on the building scale. So for the different building types. Then the layer on the renewable energy potential, which is based on the geographical information, so geographical constraints, but as well, so geospatial constraints, but as well temporal constraints, for example, looking at the weather condition. And then assessment of within a portfolio of energy systems, how to deploy a given system, considering those constraints, the demand, and existing infrastructure as well. So this can be in an iterative approach tackled by building different scenarios, for example, taking into account different efficiency measures for the demand, which can be computed, calculated, before trying to optimally provide a range of solutions for the integration of those renewable energy systems within the city characteristics for a given cities, let's say. So we can break down in three main components the methodology. So starting with the energy demand modeling, following up with the renewable energy potential mapping, and finally the distributed energy systems optimization. One of the implementation of the tool which is unique is the possibility to assess the energy demand based on the details available from the city itself. So the granularity on for example, the building characteristics, whether we are able to have a geospatial reference on the portfolio of buildings within the city for the different end use type, but also looking at, for example, whether we are able to have also measured data in order to calibrate and provide a better estimate of the demand, which can be calculated in three different ways. One is using simulation model for archetype building, which are tackled by the tool itself. So there is data mining technique which are implemented to be able to sort out different buildings for which simulation is provided in order to get an estimate of the demand. Purely calculation based on the heating degree days, for example, or combination with measured data. The algorithm which are implemented in the tool allow through clustering and extrapolation to get an estimate of the demand at a quite granular level, which is also based on the user input. So the city, which data can be provided from the city on the characteristic of its buildings. This can be then linked to a lower granularity level understanding of, for example, industry or mobility sectors, energy demand in terms of fuel consumptions or electrification, for example, or the use of hydrogen, for example, for industry. This can be combined as input in order to create the first geospatial layers on the demand patterns. This layer is then combined with the renewable energy potential mapping, in which we look at the geospatial constraints, which are limiting or enhancing the deployment of renewable energy in the urban context. So, for example, the availability of rooftop, the availability of road, for example, for vertical wind turbines, etc. Those constraints are provided and calculated with the tool through the use of a map, which is an input from the city, and can be also refined by the user. So in order to, for example, limit the availability of the rooftop for PVs, for example, based on the policy, etc. The calculation of different renewable energy potential can be done in a geospatial and temporal fashion, using, for example, weather file information, which are also included, or can be provided on a yearly basis, for example, for organic waste from municipal solid waste, which can be based on GDP and economics, so more socio-economical criteria. Then the user can, of course, also provide understanding of the potential to import renewable energy to the city, for example, with, for example, a seasonality. If we talk, for example, about biomass based on the seasonality of the crops, we could estimate the potential renewable energy which could be bring into the city from within the boundaries, outside boundaries. So then after we can visualize actually the potential for the different buildings within the scope of the analysis, and then look at the last layer, which is the integration of energy system solution. So based on the demand and the potential, the distributed energy system solution is providing a portfolio of technological solutions which range from converters, for example, in order to transform, for example, solar energy to heating or to electricity, storages, or networks infrastructure. So existing networks, but also potential future networks. We can discuss, for example, district heating networks, which could be considered within the range of solution that is provided to the tool. The different solutions can be provided based on the scale, so range of scales. For example, we can consider system which can be applied at the building scale or at larger scale for a district, for example. The parameters for the efficiency, the costing parameters, as well as, for example, life cycle, minimum part load, ramping constraint, etc., needs to be based on the range of the scale of applicability of the given system which is considered. Then I will go more in depth, for example, in the formulation, which allow to optimally provide given solutions in order to decarbonize the city, so minimize, for example, carbon emissions, but looking also at the cost. So we have seen that the demand can be provided based on simulation method or a data mining method. Finally, those layers of demand on renewable energy will be considered by the problem formulation, which allow then to, based on the portfolio of technology, provide an optimization results in terms of deployment of renewable energy to match the given demand and using the given renewable energy potential. So the problem is formulated as a mixed integer linear programming in order to consider different constraints for the technology, or, for example, the range of size, the part load, the minimum load of, for example, cogeneration units, which can also be considered, or the different economy of scale, for example. Finally, a given solution will provide the location of the energy systems to satisfy a demand which is geospatially referred and temporally referred, and provide an operating strategy. The operating strategy then can be input to a network simulation package, which allow to understand more in depth the power flow constraints to see if a given sizing of the system could actually satisfy the existing grid, or do we need, for example, to upgrade the grid, or what are the requirements for the grid in order to handle, for example, the intermittency of the energy system, which would be provided as a solution, given also, for example, the storage, which would go along with the different systems. So we have been looking at the tool itself. The goal is to integrate the tool in a platform, and the platform is combined, so it's divided in two main components, basically. So the two main components, one is working more as a dashboard in which a city, so a user, which would be, for example, city stakeholders, would be able to enter data, which are, for example, renewable energy potential, renewable energy installed capacity and future project, and, for example, timeline with renewable energy targets that Yong mentioned before, for example. And finally, here are combined as well the results of the platform, which can provide an understanding of the share of renewable energy which can be achieved based on the scenario in terms of measures for inefficiency measures, and as well as strategy, for example, for transportation and industry. So that's one part of the one component of the platform itself, and the other component is actually the tools I just described, which allow to do the analysis based on the requirements from the city. So it's divided, as we have seen, in three main parts, which is the demand modeling, in which the user can visualize the results at different scale temporally for the different buildings, for example, or per district, or aggregated at the city level, and then have an understanding spatially of the demand for each of the building and provide also do further analysis, for example, in terms of peaking, average, or etc. Then the renewable energy potential mapping allow the user also to specify some constraints for the different energy carriers which are considered. For example, we can apply feed-in tariff. We could look at different cost for carbon factor, for example, for the energy carriers, and also limit the supply of given energy resources which could be imported. For example, if we import green hydrogen to the city, we need to understand whether we would produce the green hydrogen within the city or we would import green hydrogen. So we can have a cost for the importation in order to first produce it within the city. This is also linked to a policy and a strategy. Then we can visualize also the renewable energy potential temporally. And finally, worked on the portfolio of technology which could be included. We have a database that we are working on, regional, which provides, for example, different technology which would facilitate the integration of renewable energy for the cities, and in which, for example, a user could have an understanding of the different characteristics to have an understanding of which parameters are required. But the user can as well identify the characteristic of the technology within the local condition in order to implement it within the platform to get better results based on the local technology, how they work, and being able to obtain this feedback within the platform. The technology could be implemented at different scale as we discussed already, and the user can provide some constraints which are geospatial in order to implement a technology for a given buildings or given district, or withdraw a given technology which would not be candidate to the optimization problem. Then we can visualize the set of candidate energy technology considered for a given problem based on the different scenario, and then also visualize spatially what is the scope and scale of the problem. We can also identify some zone of the city in which we would like to integrate different technology or apply measures and do some testing, not on for also different districts. Finally, as a result, we can get an overview of the different solutions in terms of carbon emissions and costs, which would be achieved by being able to supply by a set of technology which would be distributed or centralized, but at the scale of the city, in order to match the given demand using the potential in an optimal way. The solutions are all optimal for different objectives. For example, minimizing the cost and carbon, but in different proportion. We can have an overview of those different systems, for example, and what is the design, the solution behind which would operate in a certain fashion, for example, for a year of operation at hourly resolution, in order to be able to provide the given demand through the utilization of those different energy systems, and then what is the renewable energy shares which would be resulting from the implementation of the system. We can have a look at the implementation of the system in the different sites, and then look at the trade-off, for example, replacing AC or replacing electric heaters by heat pump, or all this kind of trade-off on what would be the interaction with storage. Electric storage would be sufficient, or do we need hydrogen storage, etc., etc. Finally, the solution would be tested also against power flow constraint in order to understand whether the grid could satisfy a given solution, which is much more distributed. With that, I would like to conclude the presentation with this slide, which is about the aim of the tool. So the tool is we are constantly developing the tool and platform it, and it's a continuous exercise in which we developed in a constant feedback loop with the different city we worked with, and the mechanism developed allows to get benefits out of a push and pull mechanism, for example, in which we have data, big data, which can be utilized in the tool, and which actually allow to produce more knowledge and also to refine the calculation and produce better estimate on the renewable energy integration. So it's a tool that on which we work. Also, it's implemented in different modules. So all the modules can be further developed and integrated separately. So the collaboration environment is very helpful to continue working on this tool and keep the knowledge as a database, basically, to keep improving and better evaluating the potential of the integration of renewable energy in cities. So with that, I would like to conclude the presentation. I will hand over to Yong also if you wish to eventually add something. Thank you very much for your attention.
Thank you.
Thank you, Julien.
Thank you.
Yeah, hand over.
Perfect.
Thank you very much. Thank you very much.
To you, Professor.
It is very clear that human beings create problems, and now we understand that we need to use, as human beings, all related information together and make a systematic analysis. And also we should involve the stakeholders or the needs or the human activities, all transportation, industry and residences and everything. So we are living in a global prison. So we learn by mistakes. And now IRENA, I know that Dolph Gillen, I was with him in this energy technology system analysis program. We need to plan the future with the technologies of the future. Otherwise, we cannot define the problems correctly, and we cannot find solutions which can be implemented. So what you are doing in IRENA with the leadership of Dolph Gillen and other colleagues with the global experience, you are doing a good work. And now we need to start from the cities, please, because the problem is started in the cities. You cannot escape to the forest and find a nice living space over there and save yourselves. So cities are important, and the most important thing is the people, human beings, should talk together, find solutions, and be happy with the common solutions. Otherwise, we cannot save our living space. Okay, thank you very much for this methodology and everything. Now, I would like to give the word. I would like to give it to Professor Şener Oktik to show us the importance, or to let us know the developments in the photovoltaics and its role in the future zero emission global world and countries, how PV can contribute in that sense, and what's the role of renewable energies and mainly photovoltaics in this transition. What is the synergy between energy efficiency, photovoltaics, and green hydrogen? The floor is yours, Professor Oktik. Thank you very much for your participation.
And thank you very much. Thanks a lot. But I can hear my sound twice. I like to thank Yong and Julien for that very fulfilling presentation on the platform they are developing, or I hope it will be disseminated all over the world. But I will be sharing my idea on the really buildings only. I'm Şener Oktik. Currently, I'm the Honorary Chairman of Turkish Solar Energy Association. I'm also a member of Şişecam Board of Directors. As you know, Şişecam is the largest glass producers of Turkey and the 5th largest of the world. And currently I am the senior lecturer at Kadir Has University. This is my disclaimer. This all the information I'm going to present here is collected for the purpose of this talk. When it comes to the buildings, since this subject is zero energy buildings, we always sort of really take the idea of how we really choose the facades of building design. We always like the views, daylight and sun path. We like to be self-shading, window to solid wall ratio. We are always concerned. Most of daylight we like to get in, but we need some walls. We like to reduce the ecological impact of this facade, and of course the recycling idea. When we really think of this kind of building, when we look at the building now, the architecture has changed significantly. Can you hear me? Hello?
Did you share your slides? No, not yet.
Yes, I did.
But we cannot see it. Maybe the organizers should do this.
Just a minute, I'll share again.
Okay.
Can you see it now?
No, not yet. Hocam şimdi organizatörler share ediyorlar hemen şeyinizi. Teknik ekip hemen paylaşacak sunumunuzu hocam. Sizde share screen şey gözükmüyor mu hocam sağda?
Gözüküyor.
Yani sağda tıkladığınız zaman sonra share screen'e bastığınızda ama ekranı açtınız mı sunumunuzu?
Tabii sunum ekranda. Sunum burada.
Açık. Ondan sonra şeyi açın tekrar. Share screen yapın ve çıktığında da
Paylaş yapıyoruz. Oldu mu?
Olmadı. Oldu hocam. Tamam.
Görüyor musunuz? Peki, harika.
Evet. Şu anda görüyoruz hocam. Çok güzel.
Devam
Buyurun
ediyorum.
devam edin. Devam edin hocam. Buyurun.
This is my disclaimer. When I'm talking about the buildings, how we choose the facades. But when we look at the buildings now, I am sharing 14 super tall residential skyscrapers in the world with building time. As you can see, the buildings are glass. Facades are glass. So we have to do something on the glass for energy saving and energy production. In fact, when you look at the size of the facade in USA, currently between 5 to 7 billion square meters. This is enormous amount of area where you can produce electricity. These are shared already globally. Residential and commercial buildings energy consumption in Europe 40% almost. So IRENA is quite helpful to really tackle with this. In the houses, most of the really demand in lighting, increasing demand for space heating and cooling. So we have to look at really those areas for energy efficiency. There are really certain ways of doing it. For instance, when you look at the double wall or single brick wall, the U value, probably I have to say a couple of words on U value. U value is a thermal transmittance coefficient, which is the energy really passed through per square meter per degree difference. When you look at the single brick, it's a 3.6 watt. When you go down to really the glass, single pane glass, it is 5.8, almost 1.6 times of single brick wall. When you have double glaze, it's almost 75%, and double glazed coated glass windows is almost quarter of the single brick wall. But when you improve the wall, you can see that you can go down to 0.5 watt, half a watt per square meter per degree difference. So our aim is really make the windows close to that value. But when you really do that, you have to tackle the effective daylighting of the facades. As you know, the spectrum is the starting point of any discussion. As you can see, most of the spectrum in the visible region, most of the energy in the visible region, and significant in the near infrared. But these are the direct. But indirectly, you got some technical term, but blackbody radiation. So when you design anything, if you are in the hot climate, transmittance should be this kind of small filtering. But in the cold climate, you need a larger filtering glass. Of course, you've got the glass emissivity, which is the blackbody radiation from the glass. Of course, in that case, we've got conduction, thermal radiation, solar radiation. When you see the windows for zero building, you can see there are lots of different parts transmitting the energy from one side to other. We are concentrating on the middle of the glass, and I will be talking on the low E coatings, how we can tackle with that. As you can see from the window, you can have some U value related to frame and the casement, and U value of the glass. Total is the U value of the window. There are some description of the words I'll be really talking on, but the frames of insulating buildings, it's almost 30% of the U value. Emissivity is an important concept in where you can see expressed between 0 and 1. This is the ability of the material to radiate energy. If you heat any material, it is hotter than or colder than around, it will emit some energy. I'm not going to go in detail of this, but you can see, you can have thermal conduction of the heat through windows in and out, but you can have the radiative one. So the actual emissivity and the coating to tackle with emissivity is important field in the energy saving area of the facades and the buildings. There are different kind of really approaches. If you have double glaze, triple glaze, where you put the coatings, you have different weather conditions and you sort of deal with different combination. But you can go down to 0.7 as the U value, which is quite good, very close to a double brick wall with a foam field. So we can have really facades down to 0.7 watt per square meter energy transfer. Coating is important issue in that case. We can have non-switchable or passive coatings. These are sort of really reflecting the energy, passive low E or solar control low E. And IGU units with low emissive coatings, of course, it's a little bit expensive, but it can reduce 30 to 50% of the energy loss from the middle of the window. When you take off the coating, if it is just reflective, this is the solar spectrum, as you can see. In the visible region, if you have the ideal glass, it should be in the black one. But when you have the reflective, as you can see, you reduce the visibility 50%. So it's a problematic. Sometimes you don't want it. So you can have a low E coatings for energy efficiency to tackle with. So you can reflect the infrared and you can transmit the solar radiation and transport of windows. For this, there are different coating layers from gold to silver to copper, but common one is the silver because the gold is expensive. This is the kind of really state-of-the-art coating. So you can have single, double, or triple silver layers to tackle with the infrared region of the spectrum. which is quite important. You can see all those skyscrapers now applying depending on which weather conditions they are in. So climate pass, you can really choose one of those depending on the cost you can bear with. This is showing this. For instance, if you got 100%, you see this, say 85, this, and down to 25%. But you are really between 70 to 55% in the area you'd like to have it. For instance, the Şişecam temperable low E is quite good product now on the market, successfully employed in Turkey and Europe and all over the world. There are smart windows, of course. Smart windows is the passive self-regulated control windows. This is thermochromics, photochromics, and gasochromics. And active dynamic control windows. This has electrochromic, thin film devices, suspended particles, liquid crystals, and the liquid crystal devices. This is a good example of thermochromic, for instance. If you sort of really coat the windows with the thermochromic, as you can see, depending on the environment temperature, in the morning you have this, you can almost blocking all the sunlight going in, but in the evening you got nice and clear. This is the kind of physics of between metallic state and semiconducting state of the coating. This is a quite good science engineering application in here. If you go for photochromic coatings, for instance, in the cars, in the strong sunlight, you can see the car windows is quite dark, but under the faint sunshine, you can see that it's quite nice. You can even have the gasochromic coatings, reducing oxidating gas. This is another applications. But electrochromic thin film devices are the active dynamic control devices. Electrochromism is a color, transparency, or other optical property of the material change in response to electrical charge. By charging or discharging, you can really play with the all optical color transparency. It's quite a versatile applications. As you can see, on and off position, you can have 60% light going through or only 1% going through, depending on your application. There are suspended particle thin films. As you can see, suspended particles involves two pane and then some particles suspended in this liquid. And you can really charge on and off. You can really arrange those particles to let the light or stop the light. The light could be 0.5 to 65%. This is quite slow. There are some problems. But if you want to, and you in the between, you can have between values in this. For the liquid crystal, as you can see, you can have on and off very fast, but you can have only on and off. You cannot have in between values. So the current buildings in the platform, I don't know how much Yong and Julien is involved that you have active dynamic glazing, intelligent control in the buildings. You can have buildings controlled by temperature, solar radiation, artificial light levels, natural light levels, indoor activities, how many people there and what they are doing, privacy switching, etc. It's a quite versatile products to be controlled intelligently. I hope it will go further in everywhere. It's very limited application now. But the market is growing fast. For instance, in 2016, double glazed 3.0 billion now is 5.5. As you can see, figure I'm not going to read up. But in that, glass is an important part. In 2021, it reached over 10 billion market. But in Europe, you can see the European building stock status. 86% of glazed area in Europe's buildings are inefficient. 44% in single glaze. Still, as I said in the beginning, U value is almost 6. 42% of outdated double glazing. Today, only 2 countries apply the energy balance concept. 8 countries consider passive heat gains. 20 countries do not properly assess the energy performance of the windows. There are 100 million tons of carbon dioxide can be saved. There are 1 billion for new windows are expected to be sold by 2020-30 in Europe. So it's a big market, interesting technology. It's expected from everyone, from scientists, technologists, investors, policymakers, all platform designers. We like to really join together. In the countries, you can see the Europe is the largest interested in energy efficient windows. And this is the global energy efficient window market development. In 2027, it's expected that up to 29 billion. Now it comes to the producing energy from the windows. You can have a semi-transparent and transparent photovoltaic cell. There are significant potential. As I said at the beginning, there are 5 to 7 billion square meters in United States only, which can be turned into energy producing windows. Transparent PV windows have a power generation potential comparable to the rooftops. Anyone interested, you can go to its websites and really watch some impressive videos. Solar cells are developing from 1st generation to 4th generation currently. In the 4th generation, we've got low-cost, flexible, polymer, organic, transparent thin-film photovoltaics, but it is coming up. It is there. Efficiencies, we always follow. It's going up, and you've got very high efficiency silicon cells. Silicon cells are really reaching to theoretical value. I believe that it will punch through the theoretical value. There are newcomers like perovskite on silicon, monocrystalline silicon. This is the kind of values are recently wandering around. And when you look at the world, in 2019, there are 650 gigawatt installed, producing 4% of electricity of the world. This is mostly silicon-based rooftops or land. But when you have really facades and windows for inorganic PV materials, you can really pattern the conventional silicon, puncture it by many, many holes. Recent results come from Korea, December 2019. They claim that they have 12.2% efficient cell punctured with 100 micron diameter, which is almost 50% transparent. Then you can have thin film PV modules very thin, but of course you reduce the thickness of the absorber, so the efficiency drops down. And transparent luminescent solar concentrate is an important area. For instance, transparent luminescent solar concentrate is a new area for solar windows. What you do really, you've got some, as you can see, multiple scattering on the luminescence powder in the glass. So you can really have all the light sort of transferred to the side of the windows, and you have put solar cells and you create electricity. So you get visible light in, but the other parts, UV and infrared, in the solar cells produce electricity. Of course, you downwork the ultraviolet photons. The actual subject I like to talk about is organic PV materials. This is quite new area, but it's coming very, very high. It's continuing research on that. It is very, very important. I'm not going to go in detail, but it's very similar to physics behind the organic photovoltaic cell. You've got highest occupation orbital HOMO instead of valence band, conduction band and LUMO. You've got energy gap, you've got HOMO, LUMO, difference, etc. But same kind of physics works. In here, there are some new development in the organic photovoltaic cell. In here, you would say, okay, you said at the beginning, almost 50% in the visible. So how you can deal with the rest? Of course, you have to collect that 44% and 6% somehow, letting that 50% going through the window. This has been done, and efficiencies are almost 10% now. How they do it? They develop a new kind of chemistry. I'm not going to go in detail, but they absorb the lights there in organic materials and convert into electron hole pairs, and you create electricity. This is some technical information on anyone interested in transparent organic photovoltaic cells. But what is there? You can see you can have a product now on the market. You can have a small molecular OPV cells, polymer-based OPV cells, dye-sensitized solar cells. This is one good example. You can create quite a large pane of glass with the organic photovoltaic cell on it. You can see it's fairly transparent. You can have it on your window. You can see through. You can control the light, and you can create electricity. There are some companies, Michigan State University and MIT. Time is up. Almost coming to it.
Almost.
Yes,
hocam.
Couple of slides. Michigan State University and MIT are leading the research, and some companies, Ubiquitous Energy, now have some product on the market. As you can see, organic, transparent photovoltaic devices producing electricity. This firm, Ubiquitous, claimed that almost 10% efficiency. 5Z is European manufacturer, but they create those luminescence on the side of the windows. Bright Solar sees some organic ones. So transparent organic photovoltaic cells, integration into insulating glass units, selectively transmitting the visible light as you wish, selectively converts instant ultraviolet and infrared light into electricity, simultaneously block the transmission of unwanted solar heat. But it's early stage. Power conversion efficiency is in progress. 10% is not enough. We need higher. Visible light transmission should be improved. Now almost 50-60% there. Solar heat gain coefficient needs to improve. Emissivity and color. This area is a very important area for zero energy building, because it's coming. Our facades, our new buildings, all glass, all surfaces, glass surfaces, it is applicable to all. This is my last slide. As always, use this one. The egg is there. What you paint is your imagination. Thank you very much for listening.
Thank you very much, Professor Oktik. How powerful is the energy coming from sun? If we use it cleverly, this helps a lot for our transformation and the solution in energy. Thank you very much, Professor. It was a very comprehensive presentation. Now, as we see, we need to really approach very systematically and bring all information together and plan the future with the information of the future. So with the availability of renewable energy everywhere, so the local activities are becoming really important. We say this community power. We know that the solution in energy is first energy and use efficiency, this to reduce the size of the problem in all human activities. Then, since renewable energy sources are high entropy sources, they are everywhere. So they reach directly to the point where the energy carrier to be produced from them can be used directly, locally. So that's why local people's involvement, local people's decision, and local people's ownership is becoming very important. This is mainly the energy end use efficiency is becoming very important. So to do anything nice, first we should start with energy end use efficiency. This means, of course, Professor Heperkan is really an authority on this and scientifically and doing many projects in Turkey. So he will show us how we can reduce the size of the energy problem by energy end use efficiency, and so that the energy planners, modelers have smaller problem to deal with, And we know that free of charge renewable energy sources are the key thing. We developed technology since beginning with 1980s in this International Energy Agency energy technology implementation agreements. And with ETSUP, we learned to plan the future with the technologies of the future. And but still, energy end use efficiency and energy saving is very important. Please, the floor is yours, Professor Heperkan. Please teach us what to do. Thank you very much.
Thank you, Professor Uyar. So that was a nice introduction. I would like to say a couple of words. I'm a simple mechanical engineer from profession, actually, but I tend to deal with energy subjects. At present, I'm a professor at Istanbul Aydın University and the dean of the engineering faculty. As Professor Uyar has told us, I'm leading and doing a lot of projects on building energy efficiency in Turkey and also in Europe. We work with the Germans and the Italians a lot. So now I would like to share my screen if I can. I hope I don't have the problems of Professor Oktik.
Hopefully.
Share screen.
Maybe we should ask from the organizers. Ömür Bey, would you please share? Do they have Hasan Heperkan there?
Yes, they do, but why doesn't they?
Maybe it doesn't work or with the share.
Highlight doesn't work for some reason.
Please, Gökçen, would you please share Professor Heperkan's presentation, PowerPoint presentation?
Let's try that again. Share screen.
Hasan Hocam, tamamen açık mı? Ekranınızda açık mı? Sunum açık ekranda açık olmazsa göstermiyor.
Sunum açık, evet.
Ekranda sunum değil mi?
Ama paylaş butonu şey yapmıyor, çalışmıyor.
Çalışmıyor.
Uygulama penceresi, Chrome sekmesi.
Belki you should authorize Professor Heperkan to be able to share his presentation. Otherwise, please share it so we don't lose time. Maybe I can reach them by phone.
Just a second. Can you see it now? Can you see the presentation now?
Something like
yes.
Yes.
Oh, yes. Please do the same thing again, please, Professor Heperkan. We have seen it first, and it went back.
Okay, I will redo it. I think what the problem is. So, now you should be seeing the presentation.
Yes. Yes. Thank you very much, Professor Heperkan. We are ready to listen. Yes, please.
Okay, now you see the presentation, right?
Yes, please make it a full presentation.
Okay.
So,
yes. Now everything should be working.
yes. You can make it
Okay.
full screen.
It is full screen at the moment. But it's let me do it with the others. Let me do it like this, if you can see it properly, because the other, for some reason, doesn't seem to be working. Can you see it now?
Yeah, but I mean, the earlier one was also nice. Yes, but you can make it a PowerPoint. That's very good now. Yes, but please.
Okay. So let me go on then, if you can see the presentation. So
yes, but Professor Heperkan, we see the other slides also on the left. You can just
yes,
make
but,
it.
But when I start the,
It's okay. I mean, do it as before. That's okay. Yes, perfect.
can you see it
Perfect.
now?
Yes, 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 perfect. Yes, that's
Okay,
good. Let's go on.
Let me go on. Okay, now
Yes.
first thing I would like to emphasize is we are looking or trying to achieve zero energy buildings. So in order to be able to do that, I find a couple of issues very important, which I try to summarize here. One is we must be using renewable energy. We must have electrification for the controls and digitalization. And more than all, we must have use the energy efficiently. Okay, so why do we need this? Why do we need the energy? Use the energy efficiently? Because the fossil fuel reserves are diminishing. We don't care really on that because we want to switch to renewables. And we also want to reduce the greenhouse gases until we achieve the 100% renewable energy goal. Okay, so what do we mean by renewable energy? Renewable energy is the type of energy that produces itself or renews itself in a shorter time than the depletion rate of the resources. Okay, there are several types of renewable energies like solar, geothermal, hydrogen, wave, biomass, and so on. Okay, now let us. I want to show a couple of slides. How are we doing on this? Here, this is the annual addition of renewable power capacity. This doesn't look bad because we are improving, we are using more renewables. How about electrification? Of course, at the present, 3/4 of the electrification is with non-renewable electricity, but the share is improving. So a 1/4% is not that bad. We're also achieving that goal also. And the renewables, investments on renewables, as you can see, are the largest portion of the investments on energy. Therefore, that is also very promising. And the electrification, who is investing? China is the leading country that is investing on renewables. And on the right side, you see that Turkey is also not doing bad. 2% is a good number, similar to Korea, Germany, in fact, a little less than Germany. So I think the table or the picture is promising. And finally, if you want to use renewables, of course, you must also be looking at energy storage. Otherwise, it is difficult to use the renewables. As you know, that when renewables are active, then we may not need the energy that much. So we have to do some energy storage. And the energy storage investments, as you can see here, are improving. That means we're using renewables more and more all the time. Okay, the global warming, climate change issue is very important. As you can see, the ozone layer was discovered only approximately 30 years ago, which is not very long. But in the meantime, we reacted quite quickly. But of course, we haven't achieved the goal yet because the Kyoto Protocol was made effective only in 2005. And of course, countries must sign the protocol, and that's only 10 years ago. So we're not doing that well, but we're getting there. And finally, I wanted to mention the Paris Agreement in 2015, where the countries decided that or that the 2-degree increase in the global temperature rise must not be exceeded, and even a better goal would be 1.5 degrees. Okay, these slides I would like to go through quickly. Turkey, as we know, does not have energy resources. We have to import our oil, natural gas, and the coal that is used for energy production is imported. And how do we use this energy that we are buying actually outside? As you can see, the building sector, we are concentrating on the buildings. Almost 40% of this energy is used in the buildings. And the electricity production is from fossil sources, unfortunately, at the moment.
Professor Heperkan, I'm sorry.
Yes.
They want to share your presentation because the one you shared is coming and going back. So I'm asking them to bring your presentation themselves. I mean, we cannot follow. So
that's why I.
Okay, now they will.
How about this one? Because this doesn't.
Okay, but they will share it completely now, and it will be okay. Please, Gökçen, please share and let Professor continue. Can you do it?
But how about this, Professor Uyar? This
okay.
doesn't flick.
Okay. Okay, now you can continue. Oh, they are going to share. Just a minute.
Yes.
Yes, here you are.
But what?
Now you can just tell them to go further to the PowerPoint which you need to be. Yes, I think that's better.
But
Is
I
it okay
don't
now?
see their. Just a second. Okay, now I see the presentation because I wasn't able to see it. Okay, I already talked on this.
Which slide? Which slide you want them to go? This is 10th slide. Go further.
Okay. I can't see the number of the slides. We must proceed. Just a second.
Okay, further.
I will tell you in a minute. I have it open on the other computer here.
After the general energy balances.
Okay, 21.
21. This is 24, 21. Okay, here we are. Please,
Okay,
we are sorry, Professor Heperkan. Please.
Okay.
Continue.
No problem, but the other presentation was okay. Anyway, okay, I will just continue. There are technological solutions, of course. I indicated the problems that we are facing, but we also have the solutions. Okay, so I will try to explain what these solutions are in the next slides. Here, I would like to emphasize on a concept which is we call cost optimal calculations, because the cost of the investments are also very important. Okay, here we did a joint project with the Germans and the ISODER, the insulation people here in Turkey. Next slide, please. Okay, and the cost optimal level is just trying to explain is where we meet the minimum of the curve between the investment and the and the cost. The next slide, please. Okay, we can also go to the other slide. I'm sorry, having problems because I don't see the full screen from my computer, and I'm having problems since I don't have the control of the the presentation. I would actually prefer the other one, where you see the slides on the left. I don't understand what problem that has.
Please do accordingly, Gökçen. Can you hear me, Gökçen? Hale getirin. Solda slaytların olduğu bir escape'e basarsanız oraya gider. Yani solda slaytlar gözüksün. Hocam takip etmekte zorlanıyor.
Ya şu şekilde
Hasan hocam bu şekilde iyi mi?
evet, siz görüyor musunuz şu anda?
Biz görüyoruz gayet iyi. Şeydeyiz 24. slide. 25'te Building Energy Technologies var. Siz hiç göremiyor musunuz hocam?
Ya bendeki onu takip etmiyor şu anda.
O zaman Gökçen siz lütfen çıkın ve hocam kendisi paylaşsın.
Evet hocam.
Lütfen tamam. Hocama paylaşma yetkisi verin. Hemen paylaşsın kendisi. Hocam siz paylaşabilir misiniz lütfen?
Tamam, yaptım şu anda. Biraz sonra gelmesi lazım sizin de ekrana.
Evet hocam geldi. Bu şekilde devam edelim uygun görürseniz.
Tamam. Okay. This is much better. Okay. So now I see the screen. Okay. So what are the building energy technologies and digitalization? The first technique I would like to talk on is the insulation and the windows. As you know, at the present we have 4 climate zones in Turkey. However, this cost optimal situation and the project that we did indicates that in order to have energy efficient buildings, we must have 6 regions, not 4. Okay, and here we have a couple of outputs from that, the U values according to the cost optimal calculation. So you see some figures here for the roofs, the facades, the windows, ground, primary energy demand, and so on. Here, there are 2 slides that you are seeing here, table 6 and 7. One is for new buildings, and the other is for existing buildings that are being renovated, because these renovations are also very important. As you know, the new energy building rate in Europe is around 1%. It's a little bit high in Turkey because of the renovation against earthquakes, but it's still around 3 or 4%. So we must do something with the existing buildings also if we want to achieve the zero energy building goal and also convert to 100% renewable energy use. Okay, so this is one of the issues I wanted to make. The second is the windows are very important, and Professor Oktik actually talked about these, so I don't want to repeat what he has already told us in more detail. Now I would like to go to the heating and space cooling part. And here we also have a lot of new technologies like condensing gas boilers, heat pumps, absorption chillers, generation. Heat pumps are very important for nearly zero energy buildings. The business as usual technology for heating now is non-condensing boilers and biomass heaters, electrical heating. However, we have options like condensing boilers, pellet stoves, biomass, and advanced heat pumps, which I would like to emphasize on in my next slides. Okay, before going to the heat pump case, I would like to indicate one more thing. Here, we must also match for energy efficiency the supply and the demand side. That is, usually we have a system, a mechanical system for the heating and cooling of the building. However, because of the seasonal changes and the use by the individuals, we don't always match the maximum amount. And if you run your systems under 100% capacity, then you lose on the efficiency. To overcome this, we split the energy demand into groups where we call these a cascade system. And by doing this and a good control system, you use these systems one by one so that at any point of operation, you only have one little one operating at the non-peak condition. So this is also very important in the control strategy for zero energy buildings. Now, heat pumps are drawing attention a lot in the future and also at the moment. But why do I want to concentrate on the heat pumps? Because remember, in the beginning, we talked about electrification. To be able to digitalize and control objects, we need to electrify them first. And when you use electrification, then you must make use of the electricity as much as you can when you are using this for heating and cooling purposes. Okay, as you know, if you want to transfer heat from a low temperature to a high temperature environment, you must perform work, otherwise you violate the second law. And heat pumps do this job very well for us, and they can also be used in the industrial applications. Now, important about the heat pump is that the heat pumps should be considered in the renewable energy case. Otherwise, especially for existing buildings, they will have no use. But thanks to the Energy Performance of Buildings Directive in 2010, the European Commission has added that using heat pumps, when you draw heat from the soil, the air, or water, this part of the heat production will be considered renewable. Now, this is very important because otherwise you will not be able to achieve the zero energy building goal. Okay, the next issue is ventilation. I added these slides specifically in this case because the COVID-19 pandemic here has brought this ventilation problem into the picture a lot, because if you don't ventilate your houses and reduce the moisture and odors and the pollutants, then we will be having a lot of problems with the virus. So ventilation is also important. It was not given that much importance before, but the pandemic that we are living has made this issue very important at the moment. Okay, and what should we do? This is, we are using, of course, natural ventilation, but the ventilation has to be controlled. Otherwise, the natural air that you bring into the environment will bring the pollutants and also the contaminants that we don't want to enter the building. So a control case, you need mechanical ventilation, and you must use, of course, heat recovery systems. And the technology is available in the market. Okay, the lighting is the LED market, as you know, is improving. Natural daylight strategies are improving. And now I want to go into this digitalization business a little bit as I am coming to the end of my my talk. Now, in the modern economies, you can't do without ICT technologies, and therefore you must use the current technology. And here, the common word that we use a lot, the Internet of Things, IoT technologies, is used in everyday life more and more. This is a network of interconnected cyber physical objects, and it is the beginning of digitalization, actually. Customers are concerned with their privacy and data protection. Manufacturers are responsible for the standardization of these tools. And the state, of course, is interested in the national defense and cybercrime. Okay, the digitalization can be used to optimize heating and cooling fluxes also, which is the topic of my talk. Digitalization is used in a lot of issues in our life, but it is coming more and more into the heating and cooling environments also. And here, with a good control strategy and a good optimization software, we can optimize the demand and the supply side, and then try to achieve the comfort conditions in homes and also in workplaces with using minimum energy. Okay, and the smart technologies and IoT applications in buildings go together, and we call these buildings that use these technologies smart buildings. And the main objective of a smart building is to maximize energy efficiency without, of course, losing on the comfort and also the demands of the occupants. Okay, so this is very important. Otherwise, you can minimize energy, of course, by not opening your heater and putting over pullovers, but that is not what we want to do. We don't want to give anything up with the comfort conditions, but we would like to use minimum energy or maximize the energy efficiency. Okay, and this is using the IoTs and the Industry 4 intelligent building applications. This is very easily achieved at the moment. Of course, the direct digital control systems is a good tool that we can use. Here, in the next slide, you can see a house that is using this technology. There are a lot of things that can be controlled in a building, but the main thing here is, remember in my first slide I said electrification, because if you don't have the electrification, then of course you can't really digitalize and then control the system efficiently. And there the heat pumps are very important for heating and cooling, because they use the electricity, and with their coefficient of performance give us more than the electricity that they are using. Okay, and here are these direct digital control systems where you have sensors, field elements, integration, and management. The sensors read the data and then pass this information to the field elements which actually operate on the valves or the dampers to control the system. And then, of course, the system must be integrated, and this is done using computers or other protocols. And the management part, of course, is where you use the optimization so that you can maximize your energy efficiency. Here is a sample such platform, like an open protocol or Lawnworks platform. Here you can see the line, and these elements are actually connected to this system, and the elements can actually communicate with themselves. Okay, and the last couple of minutes, I would like to emphasize on how are we doing, why do we need this? And this has a good connection with the Y generation. The Y generation, as you know, the people who are born between 1980 and 2000. But the main thing is these people are entrepreneurs, they are innovative, and they are mobile. And they don't want to give up from their comfort. So the technologies that I have been trying to indicate here matches with the needs of this Y generation. And that's why actually we are seeing such great improvement in the digitalization technologies. Okay, and here to achieve this demand from this Y generation, there are four issues that we should be concentrating on. One is the cloud computing. What is cloud computing? As you know, we are used to carrying our laptops. Before we had the PCs, now we are using notebooks or iPads or our notebooks. However, of course, the capacity of these machines are limited. If you start giving up on these and use a network of servers where you can use the server capacity from wherever you are without having to carry the hardware with you. So this is important for the Y generation because they want to be mobile. Okay, and the market also shows that this is improving, like the annual laptop shipments were equal in with the PCs in 2008. Now they have tripled in 2012, and now even more at the moment. The third issue is surface computing. The Y generation also doesn't want to use these keyboards and mouses anymore. They want to use the data they have with their hands and maybe with surface calculation or solid state lighting technology. So this is also something that must be done to meet the demands of this Y generation. And of course, the last thing is not only these people communicating, but also the computers must start to communicate with themselves at some point, which leads to the idea of this artificial intelligence business, which we are actually discussing a lot nowadays. Okay, but all these things go together, and you cannot actually stop the natural developments. And the Y generation is an example. That's why I wanted to point that out. This is my last slide. Energy storage is very important to achieve the energy efficiency in the buildings, so that you produce when you can with the renewables, you store them, and then you use them when you need them. Okay, this gives you the flexibility, and without this, it is very difficult to go to 100% renewable energy world. Okay, thank you for your attention.
Thank you very much, Professor Heperkan. Thanks. And now, what I'm going to do, yes, we can, okay, now that's good. Okay, thank you very much for all panelists. Maybe I should just summarize what I have noticed and remind myself again from your presentations. So what we are trying to do with my students, we are trying to develop the roadmaps of transition of Turkish cities to 100% renewable energy. Just trying to contribute global transformation shown as a direction with International Renewable Energy Agency and with European Green Deal also. We are working in the 81 cities of Turkey with my students to make that existing situation and how they can make the transition in those cities with community power development. So this is, thank you very much for the presentation of Mr. Yong and Julien for this. And now we have also noticed in these studies that with the existing kilowatt hour costs of PV systems, the recent one is Abu Dhabi, United Arab Emirates, 1.35 dollar cents per kilowatt hour. This shows that all municipalities, all cities can use PV systems to produce their own local institutional electricity with 5 or 6 times less costly than the electricity price of the cities. So this is, we believe, very important, and we are advising all municipalities to go in that direction. They don't need to look for credits, donors or something. I mean, if you need to drink water and it's the cheapest, you should go and drink the water. You should not look for support to stop drinking cyanide. Huh? So this is, now it is beginning with Paris Agreement 2015. It's clear that renewable energy is the cheapest option. Additionally, what Professor Heperkan submitted, now I understand that I'm doing something nice in Istanbul, a house. We are building a house for my wife and myself to live whatever life we have left, how many years, without putting any natural gas stove or anything, pure electrified with a heat pump and 8.5 kilowatt photovoltaic panels with a storage and with hybrid UPS controlling everything and system automation. And so that will be finished in 1 month, I think. So now after this panel, I noticed that I'm doing something nice, but it's a shame that I didn't talk with Professor Heperkan about this at all, and I didn't ask Professor Oktik about the photovoltaic panels. But whenever you come to Istanbul, opening, yes, yes, definitely. And I want your critics about this. It will be in 1.5 months in November when we put the photovoltaic panels. Today I get the call for implementation, çağrı mektubu from AEDAŞ. So it will be a nice house. I want to have Yong and Julien also come and be with us in the opening. I will invite you. And now, before we end this session, I would like to give each of you 3 minutes to just tell us your messages so that what you suggest, what we should do ourselves, and what we should ask about the society. Of course, we know that the decision makers, which IRENA is trying to inform and develop and ask them to go in the solution direction. The decision makers are important because we are paying their salaries, okay, in all countries, in United Nations also. So what would we like them to do for us not to suffer and go as quickly as possible to the solution? As we know, every year 7 million people die due to air pollution in this world, and some of them die directly, but some of them, they become sick, chronic diseases, and they die 3 or 4 years later using some medicines. And like COVID thing, people die without even taking the medicine. So now we know that after this COVID thing, we should, of course, do something for the people who are sick, try to do something for them and find vaccine and whatever thing. But the real solution, permanent solution is stopping burning fossil fuels in this environment and in this atmosphere, and letting all this coal, petroleum, and natural stay under the ground, because the living space was not started to evolve, and oxygen started to be 20% of the atmosphere. After 4 billion years ago, the Earth was like the sun, 6,000 degrees, only with carbon dioxide and methane. So in 4 billion years, the Earth cooled down, and that's why we had coal, petroleum, and natural reserves underground. They will never end. Don't believe that 40 years later the petroleum will end. They will be over there as reserves, as the Earth is as cool as it today. We stop not using them, not because their reserves are limited. We stop burning them and let them stay underground, because when we burn them, they heat up the world and destroy our living space. So that's my comment, but I want to have your comments, 3 minutes each, and then to end up this session. Thank you very much for your participation. Let's start from our guests, and Yong and Julien, one after. Then we hear Hasan, Heperkan, then Professor Şener, Oktik to make the final word. Yes, Yong, please.
Okay. Yeah. Thank you, and thank you very much. And also, this is thank you very much for the presentations. Very enlightening. And I think the key message is for the cities. They have a tremendous amount of power, and for the citizens over there in the cities, because ultimately they have the voting power. What they wanted for their cities, what they want there for life and the future. So they can choose what options, technologies can be used, and energy, resources. And in the past, if it's a centralized system, this is hard for them to imagine, how can they choose, from the suppliers and which resources available and locally. But now I think with the renewables and applications, and especially with the reduced cost, especially as I mentioned, it's a very cost competitive manner. So I think that this is they're right now they should step up and make the move and make the right choice for themselves and also for the future of the cities. I think this is the key message. If they trigger that, I think the market will change, and the regulations will change. The technology suppliers or there, I think this is the trigger point. I think they have as you mentioned, the health and also jobs as well, local jobs, the creation and the economic development as well. I think that they have great motivation and the drivers to make that change. And especially this forum is very powerful, it's very useful, and to get this message out, to get them engaged. And this is I think the job that we have been doing, and telling the people, citizens, this is what they should think of. And I hope this is a zero built, and the forum will continue and sending this message worldwide. And I'm here. Thank you for the opportunity.
Thank you. Julien?
Yes, thank you. Yes, I agree with the key points from Yong, actually. And to follow up on those points, also thank you very much for the very highlighting presentation we had before. And we can see, I think there is many solutions to achieve net zero carbon, which comes from supply side, from demand side. We have seen technical challenges. I think we need to have further collaboration on the different topics to be able to sort out which are the more effective measures that we can after get the right regulation and after collaboration between the citizens of the city and the policymakers in order to, as soon as possible, put in place the right regulation to, for example, provide. We discuss three glassing layers, for example, reducing so the U values. We discuss technology implementation. So I think we need to understand better to quantify what the impact of those different solutions from the different sides. And for that, we can only do it through better collaboration on the different topics, and as well as enhance openness, so opening the data in order to get, for example, better metrics for different cities, and to see which solution could be implemented for which cities based on which metrics, in order to better understand those the implication of the different measures. So that's what I would like to.
Thank you very much, Professor Heperkan.
Yes, thank you. I will be very short now because I think I used a lot of time during my presentation. I would like to make 3 points, very simple. The first one is we must concentrate on renovations and existing buildings, because if we want to improve something, we have to change them. Yes, we can use a lot of technologies when we are building the houses from scratch, but most of our inventory is on the existing buildings. So we must convert these to or try to bring them to be non-zero buildings. So renovations are very important, and their energy issues must be the key point when making decisions. The second thing is to the decision makers, actually. This is economical because you have to invest, okay? And therefore, the decision makers, the state should concentrate on incentives to make these transformations realizable for the individuals. Otherwise, it will not work. And the third point I would like to make is we must use the technology. Don't be afraid of the technology. Don't think that robots are going to control us in the future. We must use the technology. Otherwise, as I said, we cannot achieve our goals. Thank you.
Thank you very much. Now, Professor Oktik, it's your turn to make the final words of this panel.
Okay. Thank you very much for all the analysts for their presentations. Well, I've been dreaming on photovoltaic since 1978. On those days, I was working on cadmium telluride. And the idea was, if we reach the level of 10% efficiency, it will be winner. All over the world will be photovoltaic. Now it's around 27 something. And the cost of per watt is around something like really several $100s. Now it is only 25 cents. But when we look at our environment in the cities, the buildings are glass now. All the facades, windows are glass. Although building integrated photovoltaic always considered as rooftops, some components, non-transparent components of facades, but the technology coming up on totally transparent organic photovoltaic is a winner. When you think of the actual window, area of windows, area of facades, or those building glasses, there are significant potential. Of course, currently the efficiency is low, but when you think of the story of photovoltaic coming with efficiency and coming down with price, this will be the winner. So the organic, transparent organic photovoltaic should be taken very, very seriously for zero energy buildings. For new buildings, especially. For old buildings, it's not that difficult. There are films to be covered with the windows, but please do promote transparent organic photovoltaic in the field of photovoltaic energy conversion for zero energy buildings. For the future architectural designs, we hope the architect would be believing in transparent organic photovoltaics. And probably Tanay also put transparent organic photovoltaic on his windows. I don't know how much sun is coming to his house, but doesn't matter. It still produces electricity. It will be a winner because of the area available for this kind of application. Thank you very much.
Thank you very much. Unfortunately, our building has a facade looking to the south, fully whole day, and the roof, the windows are on the east and west and really blocked. But maybe we can change them, or the other components of in the garden. We may think about it. I will ask your opinion on this, because it's only four windows in two sides only, which is east and west, and is a very small building. But let's see. Yes.
Please believe me, we'll be hearing more and more on transparent organic photovoltaic windows in the near future. It will be with us.
Okay.
I believe in that.
Perfect. Heat pumps also are very important, as Professor Heperkan said, but now we have excess natural gas. We want people to consume natural gas. So the heat pump implementations are becoming very expensive because they don't sell too much in Turkey. If I'm correct, Professor Heperkan, if I'm not correct, may correct me. So the market is not developing for heat pumps. That's why they are still expensive, because we are distributing natural gas to everywhere and using natural gas. So in Berkeley, California, natural gas is not allowed anymore in the new houses. It's forbidden. And since the fossil fuels, when there is more demand, the fossil fuel resources are getting more expensive and the implementation. But with the renewables, it's the other way around. Since the resource is free of charge, as more people use it, becomes more cheaper. So it's a little bit decision makers' policies. They need to support the new baby born, which is or the future needs to be developed and supported. So this is renewable energy and implementations like building into transparent photovoltaic systems. So let's hope for the best. And thanks International Renewable Energy Agency again, with the valuable work doing for globally for all countries. And I'm very proud that as EUROSOLAR, we have contributed as the establishment of it with our old president Herman Scheer, and with our as vice presidents. Thank you very much to all. Thank you for your time. We believe that in your fields, energy efficiency, photovoltaics, and other system analysis and development of tools for cities, for implementation, you are doing a great job. Let's stay in contact and do our best and make our happiness from this good cooperation and development. Thank you very much to all. Thank you. Thank you very much.
I would also like to thank Gökçen and the technical people who made this platform available for us. So let us conclude with a thanks to them.
Thank you very much.
Thank you.
Also, Kaan,
you speak for all of us.
yes, yes. And also Kaan Bey and his team doing a very good thing, bringing all those people together. Thank you very much. Have a good night.
Thank you.
Hope to see you soon in the future. Let's be together, work together, and let's be happy together. Thank you very much.
Yeah, thank you for your moderation. Excellent.
Thank you.
Bye-bye.
Bye.
Bye.
Bye-bye.